This is our DOE project running with the Energized Engineers. We are Team 3, consisting of Jason, Mackenzie, Noe, and Marcel. That's a wrap.
Hi, I'm Marcel, and my main job was to edit the video.
Hi, I'm Jason, and my main job was as the runner in the experiment.
Hi, I'm Mackenzie, and my main job was to record all the data.
Hi, I'm Noe, and my main job was doing the presentations.
And we are the
Energized Engineers!
When we were selecting which experiment we wanted to do for our DOE, we wanted to focus on physical activity, and we had a knowledge of running and the shoe type and also the terrain type. And so we wanted to build off that, and so we decided to observe the combination of wearing Vans, which are pretty much the lowest form of shoe that you could run in, and then running shoes, and then on a grassy terrain and then a concrete terrain to get the two different kinds of terrain.
The experiment factors that we used were type of shoes and terrain type. The high for the type of shoe was running shoes, and the low was the Vans slip-on shoes that don't lace up. And the terrain type for the high was concrete, and the low was grass.
The response variable was the time that it took to complete the 15-yard dash.
Our experiment procedure was that one group member will be selected as a runner. They will run a 15-yard dash for 40 times. For the first test, he will be running in Vans and in the grass, and then 10 trials will be performed. For the second test, he will be running on grass but wearing running shoes. The same procedure will be done for the third and fourth test, except the runner will be running on concrete. The data will be put into spreadsheets, averaged, and analyzed.
Ready, set, go! Ready, set, go! Ready, set, go!
It's just all alone.
Ready, set, go!
And then this is the data we gathered from running on the grass. As you can see, it was half a second faster when you were wearing running shoes than with the Vans, and also we had three asterisk marks because on two of the trials I actually lost my shoe, as you saw in the previous video, and then on the last trial I actually was tripped up by the loose shoes. And then for running shoes it was just pretty much all pretty normal. And then on the concrete, the same thing happened. I lost a shoe when I was running with Vans, and it was also, which is very interesting, about half a second faster when you're wearing running shoes. This is our plot, and you can see from the plot that we graphed the y-axis as the time and the x-axis as whether or not it's the high or low of the terrain. And so there's two different lines. The one on top is for Vans, the one on the bottom is for running shoes, and they're almost parallel, so there's fairly low interaction between Vans and terrain.
According to our data results, when Jason ran the 35-yard dash wearing Vans on grass, his time was 2.853 seconds.
When I ran on grass with running shoes, the result was 2.36 seconds.
And when he ran on concrete with Vans shoes, he ran an average of 2.558 seconds.
And when he ran on concrete with running shoes, he ran an average of 2.005 seconds.
The best combination in our experiment was running shoes and concrete, and the worst combination was Vans and grass, thus proving that concrete provides a better surface to run on, and running shoes are more optimal than Vans to run in.
This is our prediction equation. We used a similar equation to the parachute drop with the grand average and the factor A optimum level average and everything like that. And so we did that, and we got a minimum time of 2.02 seconds. And then we did a confirmation experiment and got an average of 2.099 seconds. So our prediction equation was fairly accurate. Of course, it's not going to be exact because there are is human error since you are testing with humans, but it is fairly accurate considering all factors.
Some of the significant factors that we saw in the experiment were that the grass had less friction and it was an uneven surface. The pavement had more friction and was easier to run on due to it being flatter. Running shoes were tighter on Jason's feet because they're made to run with and they bend very easily. And Vans were loose and continued to fall off during the experiment. And this is because they're not made to run with due to lack of the support in the shoe. And all of these factors we expected to see in the experiment.
Our final conclusion is that the optimal combination is running shoes on concrete followed by running shoes on grass. This shows that the type of shoe has a greater effect on the runner's performance than the surface type. However, the surface type still has some effect on the results.
For further research, some recommendations that we had were that we wanted to see what happens when a man versus a woman's running, also if there's a difference on how tall you are, and then also the level of athleticism and endurance that you have. And then also we wanted to branch off of terrains and see all different kinds of terrains, maybe uphill, downhill, dirt, or something like that. And then different kinds of running shoes and maybe even cleats if we're running on grass again. And then temperature due to just the effects of some colder weather and hotter weather as far as exhaustion. And then the last effect would be the altitude, since it is harder to run at higher altitudes than at lower altitudes.
Hey everybody, this is the end of our presentation. Thanks for Dr. Poe for all the help and information. Credit to Studio Joe for all the videography. Please like this video and comment for any questions.